Hello everyone, welcome to the channel Learn Math with Shobita. Today I am discussing some linear algebra questions from JK set 2025. The first question, let Pn be the vector space of all polynomials of degree less than or equal to n with standard basis 1 x, x square and so on x to the power n. The matrix of the transformation T from P1 to P2 defined by T of P of x equal to x P of x is. So they have given the options. These are the options. We have to find the matrix of linear transformation T from P1 to P2 defined by T of P of x equal to x into P of x with respect to the standard basis. Okay, here the order of the matrix will be 3 by 2 because this is because the standard basis of P1 is 1 comma x and its dimension is 2, and the standard basis of P2 is 1 set containing 1 x x square. So the dimension of P1 equal to 2 and dimension of P2 equal to 3. Therefore its order is 3 by 2. In general, if T is a linear transformation from V to W with dimension of W equal to n and dimension of V is equal to m, then order of the matrix of linear transformation is n by m. That is, if T is a linear transformation from V to W with the dimension of W equal to m or dimension of W equal to n and dimension of V equal to m, then order is n by m. That is dimension of W into dimension of V. So order is n cross m. Let us evaluate T of 1. The standard basis for P1 is 1 comma x. So T of 1 is x into P of x. P of x is 1. So x into 1 you will get x. You have to write it as a linear combination of the basis vectors of P2. That is 1 x x square. So this will be 0 into 1 plus 1 into x plus 0 into x square. So its coordinate vector is 0 1 0. So we have to write here in the first column the coordinate vector of T1, that is 0 1 0. Next evaluate T of x. T of x equal to x into x, you will get x square. So we have to write this using the linear combination of 1 x x square. So coordinate vector is 0 0 1. So writing this is the coordinate vector of T of 1, this is coordinate vector of T of x. So 0 1 0 0 0 1. Therefore this is the matrix of linear transformation. Hence option C is correct. Next question. The system of equations x plus 2y plus 3z equal to b1, 2x minus y plus z equal to b2, 4x plus 3y plus 7z equal to b3 is consistent if b1, b2, b3 equals. So what are the values of b1, b2, b3? We have to evaluate. So let us see the solution part. A system of equations Ax equal to b is consistent if and only if rank of coefficient matrix equal to rank of augmented matrix. That is rank of A equal to rank of A B. That is augmented matrix. Okay. So what do you mean by augmented matrix? If you write the coefficient matrix along with the last column the matrix x b1 b2 b3, then this matrix is called the augmented matrix. Okay, so here we can evaluate the first we have evaluated the rank of the coefficient matrix by applying the elementary row transformation. R2 changes to R2 minus 2R1, R3 changes to R3 minus 4R1. So I will get these changes. If you want, please pause the video and try yourself the elementary row operation. And R3 changes to R3 minus R2. So the last column will B1 B2 minus 2B1 divided by B3 minus B2 minus 2B1. So here in the coefficient matrix after elementary row transformation we got the last row is completely 0 and it contains the maximum number of linearly independent rows is 2. Therefore the rank of the coefficient matrix is equal to 2. Okay, so we know that. So here the rank of the coefficient matrix equal to 2. Therefore the given system of equation is consistent if and only if the rank of the augmented matrix will be equal to the rank of coefficient matrix which is equal to 2. Okay. So here to get the rank of the augmented matrix as 2, we have to put B3 minus B2 minus 2B1 equal to 0. So what are the suitable values for B3, B2, B1? Let us see. By putting each option, the values putting B1, B2, B3, you have to get 0. Then that is the suitable value of B1, B2, B3. Okay. To get the rank of the augmented matrix as 2. Now let us check each option. Option A 6, 7, 7. Put B1 equal to 6, B2 equal to 7, B3 equal to 7. So you will get B3 minus B2 minus 2B1. This is not equal to 0. So option A is not true. Next, let us check option B 0, 1, 2. If you put B3 minus B2 minus 2B1, wherever B3 put 2, wherever B2 put 1, wherever B1 put 0. So after evaluating, you will get 2 minus 1 minus 0, 1. That is equal to 0. Next option C 1, 1, 3. B3 is 3. So 3 minus 1, 2. 2 minus 2, 0. So you will get it as 0. Therefore option C is the correct one. Now let us check option D. The value is 1, 2, 0. Put B3 is 0, B2 is 2, B1 is 1. So you will get minus 2 minus 2 minus 4 not equal to 0. So the only option is the option C. That is, if you put B1, B2, B3 equal to 1, 1, 3, then the system is consistent. Therefore option C is correct. Next question. The eigenvalues of the adjoint matrix of matrix 2, 0, minus 1, 0, 2, 0, minus 1, 0, 2 are option A 1, 2, 3, option B 1, 1 by 2, 1 by 3, option C 1 by 6, 1 by 3, 1 by 2, option D 2, 3, 6. Okay, so here they have given the matrix A. We have to find the eigenvalues of the adjoint matrix. So what is the relation between eigenvalue of a matrix and eigenvalues of the adjoint of a matrix? Let us see. If lambda is an eigenvalue of a matrix A, then determinant of A by lambda is an eigenvalue of adjoint A. Given A is equal to 2, 0, minus 1, 0, 2, 0, minus 1, 0, 2. Here trace of A equal to 6. Determinant of A while calculating 2 into 4 minus 0 minus 0 minus 1 into 2 minus 0 minus minus 2. So 2. So you will get 8 minus 2 equal to 6. So here we know that for a matrix A, sum of eigenvalues is equal to trace of A and product of eigenvalues equal to determinant of A. So here sum of eigenvalues lambda 1, lambda 2, lambda 1 plus lambda 2 plus lambda 3 is equal to 6. Similarly, its product is equal to 6. That is, both the trace and determinant are both are same. So we have to find the lambda 1, lambda 2, lambda 3 such that its sum is 6 and product is 6. So the only possibilities are lambda 1 equal to 1, lambda 2 equal to 2, lambda 3 equal to 3. Therefore, eigenvalues of adjoint A is given by determinant of A by lambda 1, determinant of A by lambda 2, determinant of A by lambda 3. That is 6 by 1, 6 by 2, 6 by 3. So you will get 6, 3, 2. So let us see what is the option 6, 3, 2. Option D is the correct one. Okay. Next question. If A is a matrix of order 3, then matrix 3 with 1, 2, minus 1 as its eigenvalues, then adjoint of A is given by. So how to find the adjoint of a given matrix? We have to find the adjoint of A in terms of A. Okay. So let us find the characteristic polynomial of A. They have given 1, 2, minus 1 are the eigenvalues of the matrix. Therefore, characteristic polynomial is given by x minus 1 into x minus 2 into x plus 1. What do you mean by characteristic polynomial? Okay. How to find the characteristic polynomial? If the eigenvalues are given, if A is an eigenvalue of matrix A, then lambda minus A is one of the factor of characteristic polynomial. So here 1 is an eigenvalue, therefore x minus 1 is the one of the factor. Since 2 is an eigenvalue, x minus 2 is another factor, and minus 1 is an eigenvalue, x plus 1 is another factor. So we multiplying all these, you will get the characteristic polynomial of A is x cube minus 2x square minus x plus 2. According to Cayley-Hamilton theorem, if you put matrix A in the the characteristic polynomial, you will get it as 0. So P of A equal to 0. So A cube minus 2A square minus A plus 2I equal to 0. Since determinant of A is non-zero here, because eigenvalues are 1, 2, minus 1, non-zero eigenvalues, therefore determinant of the matrix is non-zero, hence A is invertible. So we can multiply A inverse on both sides, so you will get multiplying A inverse to both sides, you will get A square minus 2A minus identity matrix equal to minus 2 into A inverse. Okay. They have asked to evaluate the adjoint of the matrix. So we have A into adjoint of A equal to determinant of A into identity. Therefore, adjoint A is given by A inverse into determinant of A into identity. That is what is A inverse into determinant of A into identity? Determinant of A is here minus 2. So minus 2 into A inverse identity, which is we have already evaluated, A square minus 2A minus I. Therefore option B is correct. Thank you friends. Please share and subscribe the channel. If you like the video, please like the video and share the video, and please give support to me. Thank you.